So to complete the last step, or the last part D of this particular problem involving densities and percentages using the factor label method, I have been given a new piece of information which I want to write down, step 1, with numbers, units, and label. This is gallons and solution, to go along with all the other numbers, units, and label I can derive from the major question itself. Now, I start with what quantity am I being asked for? And in this case, a mass of bromine. And I immediately look at my data and identify it in two places. Here's one mass of bromine, there's another mass of bromine. Now, I look ahead and see that the thing that I have to make my final cancellation with is solution. So you see, I want to get from mass of bromine toward solution. And if I use this mass of bromine, it's just going to take me to the other part of sodium bromide, which is sodium. But if I use this mass of bromine, it's going to take me to sodium bromide. And once I have sodium bromide, I can talk about solution. So I'm going to start with this answer, that there are 77.6. I need mass units. And in this case, since eventually I'm going to work towards grams, I'm going to use grams. There's 77.6 grams of bromine for every 100 grams of sodium bromide. Absolutely true. Now, that is my answer essentially, a mass of bromine. Now, I need to cancel mass of sodium bromide. And the only thing that cancels mass of sodium bromide is mass of sodium bromide. And I have a number of choices for my mass of sodium bromide. I see it in 4 different spots. However, again, I keep reminding myself my final cancellation will be done with solution. So if I want to cancel sodium bromide, I should use one of the relationships that has solution in it, neither of which these do. And this one has sodium bromide but water. So the only real choice is this one right here if I'm going to get to solution. And I write the ratio again as 30.0 grams of sodium bromide per 100 grams of solution. I have canceled the mass of sodium bromide and introduced a new quantity, the mass of solution. But that's okay, because I can work towards canceling solution with solution. But a volume won't cancel a mass. I need a mass of solution to cancel a mass of solution. And apparently I'd like to substitute it with a volume. And that's what's so nice about a density. It lets you replace a mass with a volume if you use it. And as written, I can cancel my mass of sodium bromide, or solution, excuse me. Boom, boom. Leaving me a volume of solution. And now I can make a final cancellation of this volume with that volume, if only I can make the units consistent. So I have a little converting to do, converting cubic centimeters to gallons. And the connection from 3-dimensional cubic volumes to 1-dimensional fluid volumes is the fact that a cubic centimeter is equivalent to a milliliter. And then I can get to liters, because the conversion I know between metric liters and British gallons is through liters. So yes, 1 milli anything, including solution, is 10 to the negative 3rd liters of solution. Cancel, cancel. I'm going to need more room, so I keep right on going down here. Namely, I now need to cancel liters of solution. But gallons still won't do it, so I have one last conversion to make. 3.785 liters of solution are equivalent to 1 gallon of solution. And liter solution will cancel liters of solution, numerator, denominator, leaving me gallons. And now I can make my final cancellation. 2.55 gallons solution will cancel gallons of solution. I always check to see if specific units were requested, and this simply asks for a mass of bromine, and that's what I've got looking at me right now, a mass of bromine in grams, so I'm not going to change a thing. I'll just grab my calculator, and with 3, 3, 4, 4, and 3 significant digits, my answer should have 3, and I have 2.48 times 10 to the 3rd grams of bromine as my answer. So let's reinforce the method with one more problem. I read it carefully. I'm told a mixture of octane and benzene is 30% by volume octane. So I can write three ratios immediately from that piece of information. Got to get rid of that. There are 30.0 volume units now of octane for every 100 volume units of some kind of the mix. And then there are two other implied ratios, 70 to 100 volume units of the other part, which is benzene, and volume units of the whole, which is mix, and also 30.0 volume units of octane, one part, to 70 volume units of benzene, the other part. I then go on to read that I've been given two densities, one for octane and one for benzene. So I write them as ratios. 0.730 grams of octane per 1 centimeter cubed of octane, and 0.877 grams of benzene per 1 cubic centimeter of benzene. And then I'm given one last piece of data, namely that I have 3.5 gallons of this mixture, or solution as it's called. So step one's complete. Everything has been accomplished with numbers, units, and labels. Step two is once again ask what quantity you're being asked for. Now this problem reads how many pounds, but pounds is not a quantity. Pounds are simply units of a quantity, and that quantity, of course, would be a British mass. So I want a mass of benzene, and immediately I see it in a couple of locations. These are mass units, and that's benzene. This is benzene, but these are volume units, remember, not mass units. And these are also volume units. So actually, I see a mass of benzene in only one spot, right there. So I know immediately how to start with the answer. 0.877 grams of benzene for every 1 centimeter cubed of benzene. And I've started with my answer. Now, obviously, since it's part of a ratio, there's another quantity I don't want and needs cancellation. And in this case, it's a volume of benzene. Well, the only thing that will cancel that's a volume of benzene. Now, I see two volumes of benzene. These are volume units of benzene in conjunction with volume units of octane. These volume units of benzene are in conjunction with volume units of the mix. Which one to use? Which one to cancel? Well, I look ahead at the thing I have to make my final cancellation with, and that's a volume of mix. So it makes sense if I'm going to cancel a volume of benzene and replace it with something, the thing I replace it with should be the volume of mix so I can cancel it. I have to select units now, and the units I'm trying to cancel are cubic centimeters, so these should both be cubic centimeters. And it's fair to say that 70 centimeters cubed are benzene for every 100 cubic centimeters of this mixture. And I cancel volume of benzene and substitute a volume of mix. Well, now I can cancel the volume of mix with this volume of mix if only the units were consistent. Quick conversion, a centimeter cubed of mix is a milliliter of the mix. And 1 milliliter of anything, including mix, is 10 to the negative third liters of the same thing, mix. And to get to British gallons, 3.785 liters of mix equal a gallon of mix. Everything cancels but the volume of mix. I have a volume of mix, so I should go ahead and cancel by multiplying by, and I'll have to do this sideways, 35.0 gallons of mix. And everything cancels except the mass of benzene with which I began the problem. But of course I always check step 5 if these are the units requested. And in this example, they aren't. I requested pounds. So I'm just going to continue the conversion down here. I want to cancel the grams and replace them with kilograms and eventually pounds. So I'd be sure to write this down here. that 10 to the third grams benzene equal a kilogram of benzene, so that the numerator and denominator cancel. Then lastly, 1 kilogram of benzene is equivalent to 2.20 pounds of benzene. Final cancellation, final units of the exact quantity I wanted, an amount of benzene. And it looks like we need a 3-digit answer, and the final 3-digit answer I get here is 179 pounds of benzene. Now to do the final question, all my data is the same because I'm still asking about the same mixture. However, in the second part of the problem here, I've been given a different piece of information, that we have 2.5 kilograms of benzene. However, from then on, the problem is solved the same. I start by asking what quantity is being requested, in this case a mass of octane. And so I start with that answer. Now this may be octane, but these are volume units. Same is true here. So the only mass of octane I see is part of this density. So I'll begin the problem with the density of octane, 0.703 grams of octane for every 1 cubic centimeter of octane. And there's my answer essentially. However, I want to cancel the volume of octane. Now again, I think ahead because I see volumes of octane in 2 of these ratios. Now obviously one of these will be used to cancel. However, the thing I have to make my final cancellation with is benzene. And this ratio is an octane to benzene ratio, so it makes sense to cancel the octane and substitute it with benzene, which I can cancel. So I would write the ratio as 30.0, have to pick units, and centimeters cubed seem appropriate, over 70.0 centimeters cubed of benzene. And I managed to replace a volume of octane with a volume of benzene. I can now cancel the volume of benzene with a volume of benzene. And again, if possible, I'd like to cancel it with a volume that will replace it with a mass of benzene, because I have a mass of benzene to cancel with. And that's of course where the density of benzene helps me, because every cubic centimeter of benzene is equivalent to 0.877 grams of benzene. Volume cancels, I now have a mass of benzene. And I could use the mass I'm given to cancel with consistent units. Quick one-step conversion. 1,000 grams of benzene are equivalent to a kilogram of benzene. And then I can cancel the kilograms of benzene with kilograms of benzene and get my final answer. And it looks like in this case with this 2-digit measured number, we need 2 digits in our answer, and the final answer I get is 8.6 times 10 to the 2, and the units are grams of octane, excuse me. And of course, I overlooked the fact that we might have needed specific units, but in this case where the question is simply what mass, it would be advisable to leave mass units as grams and not have to do further conversions.